My name's Steve Thompson from PCSG in the UK, so we're information management consultants. I'm an architect by profession, but then I worked for a global manufacturer for 10 years as well, developing their BIM strategy, their building information modeling strategy. And since then, I've also written reports on the future for construction product manufacturing, automation, digitalisation, and things like that. And then I'm also involved at a European level developing standards for sharing of construction product data. So I'll come on to some of those. But just as a quick run through then. So first of all, the main focus of the presentation I'll give you now, you don't need to read all of the detail there, of course, is to look at, to talk about a report I produced last year for the Construction Products Association in the UK. So this is looking at the next 10 years and the impact of digitalisation on the product sector. The first thing to look at, as one of the earlier presenters mentioned, is we need to look at things holistically. So it's not just about looking at the impact of digital technology. We need to look at the wider economic impacts. So what else is going to happen over the next 10 years, whether it's development of new technologies, such as the Internet of Things, and that eventually becoming ubiquitous. We need to look at the social aspects, so that's talking about the design and operation of buildings for the occupants that they're going to use those specifically, so thinking about mass customization and so on, but also the labour resources as well. So as we have more automation, what's the impact on local labour resources? And also to do with building performance as well. So I'll come on to some of those. The first thing we did is obviously simplify that into 3 key themes that all work together actually quite nicely. The first is Industry 4.0, you may have heard of, so basically smart factories, and that's to do with the vertical integration of a manufacturer's disciplines and functions. So for example, making sure that things like the sales and marketing functions within a manufacturing business are linked directly to the operations, product and system development and so on. But also horizontal integration, so making sure that a manufacturer can smoothly consider the flow of information and the processes between them procuring materials themselves, the production facilities, the operations, usually across different, quite often across different sites in different countries. And then also the addition of services, or servitization. So how do you provide additional services to add value to your customers and your end customers? And then finally, intelligent built assets, so the Internet of Things you've probably heard of. So how do we make sure that we can start to track the performance in use of products, for example, and how do we make sure we know the condition and the readiness of materials and products to be reused and recycled, recircled, and so on. So at the heart of all of that, the thing that pulls a lot of that together is digitization and construction products. So for the report itself, on the left-hand side, it was for the Construction Products Association. On the right-hand side is another initiative linked to this, which is called Lexicon, and this is how you start to share and democratize data requirements. So I'll show that very briefly. In terms of key objectives for that report, the first thing we did, again, was say, okay, if we're looking at what we want the product sector to be like in 2025, the first thing we need to do is come up with a vision as to what we want it to be. So the vision was world-leading, high-value digital construction product sector. So one of the first things we did is look at the economics. So the 2 diagrams at the top there, each with 3 separate columns. The first column on the left-hand side is to do with the value, the overall value of the construction product sector in the UK as it stands now, which is around £50 billion a year. The central column is to do with construction spend, so construction activity itself, building the buildings, delivering the roads and bridges and infrastructure and so on. So that includes building of buildings, it includes electrical trades, plumbing trades, and other trades on top of that as well. So the integration. And then on the right-hand side of each of those diagrams is the construction output. So do we end up with houses, offices, buildings, other building types and so on. What you can see on the left-hand side, so that's the as-is process. You can see all the confusion and all the mess between the central column and the right-hand column. What this means is that what that demonstrates there is between the construction activity and the construction output, for a project size of around between 1 million and 25 million pounds, you can typically expect around 70 to 100 contractual arrangements, subcontracts, to share information. And those tend to add cost as well as potential for errors and delays. On the right-hand side, this has been demonstrated on some real projects. This is where we have an optimized manufacturer-led supply chain. So basically when you have a consortia of manufacturers working together to deliver a specific building type. Actually, one of the early speakers mentioned Wienerberger. So Wienerberger are the leaders of this consortium, which is called Home for Life. So they pulled together with a number of different smaller SMEs to deliver a whole asset. As a result of that, and by using digital processes to BIM level 2, which is the UK government's requirement at the moment, they've demonstrated they can deliver buildings 40% quicker on site for the end client and 30% cheaper overall. And that's without taking any of the construction off-site. It's just by optimizing and doing on-site, on-time delivery. The other things we showed then is through those two processes alone, the construction product sector in the UK can grow by 39% over the next 10 years. And that's with a very conservative estimate of delivering 10% of the industry construction output in that way. On top of that, we predicted another 24% growth through other means as well, but you need to read the report for that more information. And then finally, how we look at eliminating the performance gap, so the difference between the as-designed and as-built performance. People often talk about reducing the performance gap, but actually we've demonstrated on a number of cases now we can actually eliminate the gap. So the as-designed performance is exactly the same as as-built. And that's to do with making sure the assumptions within software is improved, but also starting to look at how we can potentially certify building performance or product performance based on how it's performing in use. And we do that, again, by linking to the Internet of Things and smart assets. In terms of the data requirements, so one of the things we need to do, again, is improve the links and the flow of information all the way through the chain. So improving the links between the manufacturer and the product supplier and the building owner and operator on the right-hand side there. And everyone else in between, but we need to have that link. On the right-hand side, again, similar to one of the earlier presenters, I think there's often quite a big assumption, certainly in the UK, that product manufacturers tend to be global organisations. There are some of those, but actually 98% of the manufacturers in the UK are SMEs, and 65% of the overall micro, between 1 and 9 employees, so very small organisations. So when we're talking about working collaboratively, you've got to make sure that you address their needs and requirements, enable them to use the benefits of digital technology, not just the larger organisations can afford new technology on stream as well. One of the approaches that I'll be presenting in a second, Lexicon, is now developed into a European standard. We're working at a SEN level to develop the European standards for sharing of construction information. And that's an ongoing activity, but it's working quicker than most standards in the European industry do. This is a diagram that pulls all of this together, so just to explain very briefly. First of all, in this area here, we're talking about the project life cycle. So if we look at delivering a construction asset, starting with the red area though, so the decision to make and deliver a construction project, through the design and development and the assembly or construction of that asset. Then we have the asset life cycle, so the building's life cycle. So as well as the project side, again, we obviously really need to consider the in-use stage of that project, how we feed back information. So wherever there's a dotted line towards the top there, that's feedback of information. Information flows through back to the manufacturing and design processes. And then we have the product life cycle. So how at the bottom we can support the circular economy by making sure that all that information can be fed back to redistribute, remanufacture or recycle products. So in terms of having an optimized manufacturer-led supply chain, what we're talking about here is having a supply chain that knows exactly what it can deliver, how it can deliver, and the constraints, any particular constraints that consortia has. So basically configuration rules. So if you build using these details, you can build anything you want as long as you comply with those requirements. Using that approach on a whole building level, you can be incredibly flexible in making sure that you can deliver the buildings that you want to deliver. So it's not a case of constraining by saying everything is going to be fully volumetric or built from 4 or 5 modules. You can go down to the very small amount of detail to create those rules. What that means is the design team, if you use those rules set by the supply chain, because the supply chain is already configured, It means that as long as you use those rules, you can customize it however you want. So you can create and deliver buildings that meet the specific user requirements with the confidence that that building can be delivered and doesn't need to be changed through that process. Working together at that stage, and those can be delivered through an assembly, and again in a much more efficient, managed process to create that final smart asset. So in terms of sharing information, when I had to work for the UK government last year, again, to create the standard for specifying and sharing product information. BIM in the UK has been on quite a journey over the last 5 years. One of the issues that we've had is making sure that everyone in the chain, everyone in the design development chain, understands the information requirements. What information are they actually asking for? And what language should they be using in asking for that information? So when I was a manufacturer, we often used to get calls saying, can just give us all of your BIM information. We don't really know what we need it for, but we need some BIM information. And sometimes it was a call, can we buy a BIM from you? Can we buy a BIM, which isn't actually a thing you can buy? But it's really, people really need to understand the information they're asking for, so then they can get the adequate response. On the other side, manufacturers were often providing their BIM information without really understanding what information they're providing. So they're often providing information through third-party consultants and not really understanding the contents that they were then sharing. And as you can imagine, some were quite horrified when they realized what they were doing. So to simplify this, when we look at the implementation of digital technologies, we should be really making things more efficient. So we need to keep things very simple as a principle. And going back to basic principles, requests for information and responses to that request for information. So the process we came up with, or the concept we came up with, is what we call product DNA. Basic principle here is the red strand are information requirements. So if you want information to help deliver a construction project, you should be able to ask for that information in a language that you're familiar with. So you're not trying to learn a new digital language or computer-readable language that may confuse you. You just ask for the information that you're used to asking for. As a response to that, as a blue line, if you're a product manufacturer or anyone else providing information, the same thing applies. You should be able to apply that information, give that information in a language that you're familiar with, so you know exactly what it is that you're giving. What happens in between, this is where the exchange formats come in. So there's a format called IFC, some of you may be familiar with, and other kind of core properties that help you map through those different stages. So effectively act as a translator to speed up the process. The other thing we need to consider is how the information flows through the whole delivery and operation of a built asset. So again, we often get templates to say for this kind of product or this kind of system, and again using different software formats, this is the information that we should be providing. The problem with doing that, though, is making sure that the information can flow through those different stages. So you're not just addressing your issues, your current issues as a designer, for example. You're considering how further down the chain the information you're providing will be of value to someone. So in terms of three basic stages that are typically used at the moment, you have obtainable product information, so the second one along, which is to do with information on a product that you can purchase. So in very crude terms, a digitized product brochure. The green one in the middle, application, this will help you identify how you apply a construction product to a project. And then finally, in this area here on the right-hand side, is the information that you need to maintain that product or system in operation. So one area that's often forgotten about is the information that a manufacturer can benefit from, the production information at the very beginning. So from that we mean from the point of specification of a product through the procurement of materials, the operational phase, and then finally the installation of that product in the asset. There's some incredibly valuable information there that can actually benefit everyone through that chain. And obviously in terms of what we're talking about today, we then also need an additional start to think about the additional data requirements to support the circular economy. So how do we provide the information necessary to create the reverse logistics to enable us to do that? So that's something we're working on now. In terms of TRL levels, this approach, Lexicon, I'd say is a TRL 7, so this is going to be launched on the Construction Products Association's website in the next month or so. freely available for anyone to use, and again, it's a very, very simple online form for people to use. It's supported by over 75% of the trade associations in the UK, which means that, again, anyone at any level can freely, has free availability to say, if this is my kind of construction product or system, here's the information that I should be providing, with a confidence that it can be translated and added to by others in the chain. So significantly democratizing the data. Here's the kind of template that they'll end up with, whether it's an online form or this. So one of the important things here is as well, it's badged by the relevant trade association. So again, even if you don't tend to work with the trade associations, you'll recognize the name and the badges, so it's a recognized support. Just another couple of, very quickly, brief initiatives that are demonstrated in the report. Again, how we can start to look at data optimizing the life cycle of an asset. In terms of housing, on the left-hand side, we've been developing a viability tool, and we mean viability for a project in the broadest sense. So looking at the kind of occupants that may live in a specific area. So if you have a site anywhere in the UK at the moment, we can identify the demographic that tends to live in that area at the moment, the different types of demographic, and also their kind of housing preferences, but also how those might change over the next 60 to 70 years, where we have that information. Also, they're looking at how you can integrate new demographics into an area, and again, make sure that their requirements are delivered all the way along. You incorporate into that construction technologies, so you can make sure very quickly you can understand the implication of using different construction technologies. It's all based on current delivery models for housing, so you look at the business objectives of, for example, house builders or housing associations providing affordable housing, to make sure they don't have to change necessarily their current business models. You can use the same tool to demonstrate the benefits to them. And so we're working on the principle that we can start with sharing that information effectively. We can very, very quickly make decisions on the viability of these projects. And we've actually demonstrated, again, in a number of instances, we can create projects that would otherwise be non-viable by traditional means. We can make them viable. So housing is getting built in the areas that it needs to. Again, affordable housing to meet those local requirements, not just whoever has the most money to buy those houses. On the right-hand side, very quickly, again, this is a new generative tool, automated generation of designs and systems. I won't go into the detail of this other than to say that the principles here, I imagine if you're delivering a construction project and the client's requirements change part of the way through construction. So whether it's through, it's an office building, they need additional cellular rooms as opposed to open plan, or they may even need more space or less space. Instead of focusing on just the delivery of the original brief and the original construction process, using this approach, you can simultaneously create a lot of different modeled scenarios. So you can say, from this point in the process to the end result, the new end result, because the client now wants a change in requirements, these are the different ways we can deliver against those new requirements. It may be cheaper than the original solution, it may be more expensive, but it meets the requirements, the change requirements of those occupants. So again, instead of delivering a project that from the very start doesn't meet the requirements of those users, so again, the life cycle, in other words, would be reduced or suboptimal, we can improve the scenario from the beginning of that project. And both of those technologies, again, are TRL6, so they'll be released later this year. The report itself, that's the focus of all this, is freely available from that website. I've got a few copies across there if anyone wants one today, and other contact details there. Thank you very much.